Hi, Mike Collins here again from MicroLab. This is the third video in a series. In the first video I showed you how to calibrate a pH electrode using the MicroLab hardware and software and a standard combination pH electrode. In the second video I showed you how to set up pH titration, specifically dilute acetic acid against 0.1 molar sodium hydroxide using the MicroLab interface with a standard pH electrode and the MicroLab drop counter and drop dispenser. The result was the pH curve that you see right in front of you. So let's see how we might analyze this if we wanted to determine the endpoint. Of course, one can determine the endpoint by just going to the curve itself and interpolating it. We can select a domain and kind of just zoom in here, and it looks to me like the equivalence point is going to be somewhere in the neighborhood of 2.03 to 2.05 milliliters. This is a perfectly fine way to get an endpoint, but you can see when you zoom in that it's kind of rounded and the interpolation is a bit difficult. We're not sure if it's 2.03, 2.06, could be anywhere in here, so that gives us about a 2% uncertainty. Now admittedly this is a very small volume. If I had titrated a bigger volume, that might be a perfectly fine way to do it. Let's zoom out and show you how to use a derivative in order to do this. So let's go to analysis and plot a derivative. Now a derivative is the slope of a curve, and it would be at a maximum where we have a flex point. That is at the equivalence point of the titration. So we're going to do a pH versus volume derivative, say OK, and here we have the derivative curve. Okay, now it's full scale, maximum out at about 30. I'm going to hide this derivative. I go back over to the left hand window, click on the derivative curve, f prime of x, right click to hide the derivative. And in order to get it to maintain the proper display of the curve, we can just actually drag it over and plot it on the second y-axis. And that doesn't change the scaling on the pH titration itself. So again, we can select a domain and kind of zoom in. And when we do that, we can see that the best estimate of the equivalence point from the derivative is actually about 2.03 milliliters and a pH of 7.2. Now let's try a different analysis. Let's plot a derivative, but instead of plotting the volume versus pH, let's plot it versus the derivative to get a second derivative. So here we have now a second derivative, and we can see that the second derivative crosses the titration curve at its equivalence point. And so both of these are giving us the same results, okay, within experimental error. The best value for the second derivative comes in, it's probably a little better estimate. Second derivative goes to 0 at the equivalence point, and that turns out to be at about 2.045 milliliters. So the second derivative is a little better estimate of the equivalence point than the first derivative. Okay, let's zoom out, and you have the titration curve and the analysis. Thanks for watching.